So when we solve equations, we're going to use the same methods that we practiced in class last time. Again, the only difference is that we have base e. Okay, so this is a type 1, log equals log, so we can drop the logs. 4x minus 27 equals 15 minus 2x. And solve that out. You can always pause this if you want, make sure you can solve it yourself. And then remember to plug back in and check for extraneous solutions. You have to make sure that your arguments are positive. Okay, on 14, we would need to condense first. Remember, you have to condense before you can drop the logarithms. So that meant bringing that 2 as a power to the k, then drop. Then we're going to need to set this one to 0 since it's quadratic. Factor. So we get either k equals 5 or k equals -3. 5, if you plug back in, is okay. -3, not okay. So it would just be 5. On number 15, we would need to condense both sides. So this is going to be ln of 72 divided by 4, which is 18, equals ln of, I'm going to multiply 6 times a minus 2, so that's going to be 6a minus 12. Drop the logs, 18 equals 6a minus 12, and solve. And check, and we're good. Okay, let's look at a type 2 problem, like number 17. We would need to convert this because, see, it's just log equals a number. So our base is e to the second power equals 8x. So x equals e squared over 8. And I just want us to leave our answers in exact form like this for now. And you can see how if you were to plug this back in, e squared over 8, into the argument, it would still be positive. Number 18, ln of x over 9 equals 7. Then we convert, e to the 7th equals x over 9. And then solve for x by multiplying both sides by 9. So let's take a look at number 19. So this is, 19 through 22, these are exponential equations. So we're going to solve them by taking the log of both sides. And we want to take the natural log of both sides. So we're going to take the natural log of e to the x equals natural log of 57. And bring this x down to the front. X ln of e equals ln 57. Now, here's something important. You might want to write this off to the side. ln of e is always going to be equal to 1. Why is that? Because ln of e is log base e of e. So that's saying e to what power gives me e? That's 1. So this is 1, so that's now, we've now actually just finished our problem. Remember, you don't have to check for extraneous solutions on the exponential problems. Let's do 22. We need to isolate first. So first we would subtract the 3. So we'd have 2 times e to the c minus 9 equals 84. And then we would divide by the 2. E to the c minus 9 equals 42. And now we're going to take the natural log of both sides. So ln here, ln there. Now I get to bring this down. So I have c minus 9 times ln of e, which is 1, remember. So it's just c minus 9 equals ln 42. So my answer, c equals 9 plus ln 42. Or you could write that as ln 42 plus 9. But what you cannot do is add the 42 and the 9, because remember, ln 42 is its own thing. And here are the answers to 20 and 21 and 16. If you would like to see those, here's 16. Oops, sorry. You would have gotten -2. And then ln 19 over 4 would have been your answer on 21. I would have wanted you to leave it like this. And on 22, we did that one. So 20. Your answer would have been 3 plus ln 30.